Dear friends, welcome to a lecture of solid geometry. We are studying the sphere. In this lecture, we shall solve some problems relating to circle. We have earlier seen that plane section of a sphere is a circle, and we will solve problem to find center and radius of this circle, which is obtained by plane section of a sphere. So, first we have written how to write or how the equation of a circle is represented. We know a plane section of a sphere is a circle, and therefore, a circle together with plane represent a sphere together with a plane represent a circle. So, therefore, a circle can be represented by two equations, a sphere and a plane, because intersection of these two is a circle, and thus the two equations sphere and plane. Equation of sphere in general form is written in this form, that is x square plus etc. And plane, we know the first degree equation is equation of plane, and which is written in actually this is normal form or maybe general form, Lx plus my plus nz is equal to p. It is a plane. So, this is a sphere and this is a plane, and these together represent a circle. So, it is a circle, not sphere. The two equations together represents a circle, and thus equation of circle is given by two equations, sphere and plane. Now, we will consider a problem on it. I have written here two problems. We will solve the first problem, and it is similar to the first problem. You should try for the second problem, and therefore, I have written the answer of second problem also. First, we will see how to solve this problem. Solution of 1. It is given this is a plane and this is a sphere. So, sphere and plane together represent a circle. We are asked to find center and radius of the circle. So, equation of this sphere we should first write, equation of sphere, and this is plane, or we will draw a figure first. So, this is a sphere and its a section by a plane represents a circle, and let us suppose this is the center of the sphere, which we will denote by C, and suppose the section by a plane forms a circle here. So, I shall draw the figure like this. This is a circle formed by the section of plane. Plane is not shown in the figure, only its section, which is a circle, is shown here. And we will consider this point, or we draw perpendicular from center on this plane, and that will be Cn. So, this is point, and actually this will be the center of the circle, and we take a point P on the sphere and the circle, and that this Cp will be the radius of the sphere. So, we will first write the center of the sphere and radius of the sphere. So, what is the equation of the sphere? This is the equation of sphere. Equation of sphere is it is x square plus y square plus z square minus 2y minus 4z minus 11 is equal to 0. In general form we should write, and therefore its center is we denote it by C, and we can now write the coordinates of center directly. So, what we have to do, if the equation has in general form, that means coefficients of x square, y square, z square are 1, then we divide the coefficients of x, y, z by minus 2, that gives the center. Here x is absent, therefore the center's x coordinate will be 0. And what is the y coordinate? The y coefficient of y is minus 2. So, minus 2 divided by minus 2 is 1, and minus 4 divided by minus 2 is 2. So, these are the center's coordinate, and radius is, and let for that let P be a point on the circle or sphere. It is on the both. Let P be a point on both the circle and the sphere, on both the sphere and the circle. See the figure. Then radius of sphere is, radius of sphere is equal to Cp, and that is equal to under root of the center's coordinates, sum of square of center's coordinate, that is square of 0 plus square of 1 plus square of 2, and that is 0 square is 0 plus 1 square is 1 plus 2 square is 4 minus d. And what is d? D is minus 11. So minus of minus 11. This is Cp, or the radius of the sphere, and see it is root of 16, and that is 4. So Cp is 4. We can write here 4, and center's coordinates are 0, 1, 2. Now what we are asked to see, we have to find center and radius of the circle. So this is the radius of the circle. See np will be the radius of the circle, and that we want to find. And to find the radius of the circle, which is np, we first find Cn, and then we will use the Pythagoras theorem. Now I shall rub this part so that we can write the solution here, part of solution here. Now see, Cn we want to find out. Now Cn is perpendicular from center on the plane. Let Cn be perpendicular from C on the plane. What is the plane? See the problem. The plane is this one, and that we now write here. First we have written the center, first we have written the sphere, and then we obtain the center and radius of the sphere. Now we are considering the plane. So plane and sphere together represent circle. So Cn be perpendicular from center C on the plane. The plane is x plus 2y plus 2z minus 15 is equal to 0, and therefore we can use distance between point, perpendicular distance from a point to a plane, and that is Cn is equal to, it is. Now we have to put these coordinates of center 0, 1, 2 over this expression. So that is x is 0 plus y is 1 and plus 2, z is 2. This is a formula for distance between point and a plane. Minus 15 will be the same, divided by under root of sum of squares of the coefficients and coefficients of x, y, z, that is 1 square plus 2 square plus 2 square. And see, this is absolute value because it is distance, and that will be, this is 2 plus 4, 6 minus 15, that is minus 9, and divided by, it is under root of 1 plus 4 plus 4 root 9, that is 3, and which will be negative 3, but the absolute value is 3. So Cn is 3, and we shall write Cn here. So thus we have obtained Cn using the distance formula between point and plane, because this circle lies on the plane. And now we want to find the radius of the circle, which is np. Np is the center of the circle. Now next, n is the center of the circle, and np is the radius of the circle. Radius of the circle, and this is perpendicular. See, and therefore by Pythagoras theorem we have Cp square is equal to therefore we have Cp square is equal to Cn square plus Pn square or Np square, or that means Np square is equal to, we want Np square, that is the radius of the circle. Np square is equal to Cp square minus Cn square, or you see Cp is 4 square minus 3 square, and that is 16 minus 9, which is equal to 7. So Np square is 7, and therefore Np is the radius of circle is equal to root 7. So thus we have obtained this term, radius of the circle we have obtained. Now to find the center of the circle, which is n. So to find n, to find the center, next is to find the center n of the circle. So this we will now do, and to find the center n of the circle we write the equation of Cn line, and then we take the intersection of Cn and the plane. Now what is the the line Cn, what will be the DRS of the line? Line Cn passes through center, that is a 0 1 2, and we shall write the DRS of line Cn. Now Cn line is perpendicular to the plane. The line Cn is perpendicular to the plane, or perpendicular means normal to the plane. So what is the plane? The plane is here, or that is plane x plus 2y, x plus 2y, then plus 2z minus 15 is equal to 0, and therefore this gives directly the DRS of the Cn line. We know if the equation of plane is in general form, then the coefficients of x, y, z represents the DRS of the normal, and therefore the DRS, thus the DRS of direction ratios of the line Cn are the coefficients of this x, y, z in the equation of the plane, and that are 1, 2, 2, and with this we can write the equations of line Cn. Therefore equations of line Cn are now how to write the equations of line Cn? The line Cn passes through this point, and the DRS of the line Cn are 1, 2, 2, and we can use the symmetrical form of right line, that is x minus x1, x minus 0 divided by L, and that is 1, is equal to y minus y1, which is 1 divided by m, that is 2, and z minus z1, that is 2, z minus 2 divided by 2. So these are the equations of line Cn, and we shall suppose these are equal to r. So from this we can get a point on this line, general point. Therefore coordinates of a point on this line are the coordinates of a point on this line Cn are of the form, see from the equation we can write that are x, equate x to this ratio equal to r, and that gives x is equal to r, that is r, and then y will be 2r plus 1, and z will be 2r plus 2. So these are the coordinates of a point on this line, Cn line, and n is a point on this line. So therefore, see this these coordinates can be taken of as of n. If this is the point n, then this point n lies on the plane. See, this the Cn is perpendicular to the plane, n is the foot of the perpendicular, and n lies on the plane. So this is the equation of the plane. If this is the point n, then it lies on the plane. Lies on the plane. See, the equation of the plane is again x plus 2y plus 2z minus 15 is equal to 0, and therefore this point lies on this plane, means this coordinate satisfies this equation of the plane. So therefore we have x is r, y is 2r plus 1, and z is 2r plus 2 minus 15 is equal to 0. Simplify this to get the value of r, and that gives r plus 4r, 5r plus 4r, that is 9r, and constant is 2 plus 4, that is 6 minus 15. 6 minus 15 is minus 9. 9r minus 9 is 0, and this gives r is equal to 1. So therefore r is equal to 1 we get. So thus r is equal to 1, and with this value of r, the point is this point gives the coordinates of n, and then the coordinates of n are coordinates of the center of the circle are n is equal to, n is r plus 2r plus 1, y coordinate is 2r plus 1, z coordinate is 2r plus 2, and this is equal to, putting the values of r as 1, we get this as 1, 3 and 2 plus 2 is 4. So this is the center of the circle. So thus we have obtained the center of the circle as this one. Earlier we have obtained the radius as np is equal to root 7. So in this way, such type of problem can be solved. To find center and radius of circle, the circle is given together these equations, sphere and plane, and we have considered the first the center of the sphere, then the radius is obtained, and then this distance is obtained, that gives Pn. And to get the center of circle, which is n, we have written the equations of Cn line, and then we have taken the intersection of Cn line with the plane, that gives the coordinates of center of the circle. So this completes the problem, the solution of the first problem, and here I have written the second problem. See, you should try to solve this second problem. See, what is the second problem? Obtain the equation of the circle lying on the sphere, this sphere, and having its center at 2, 3, minus 4. We have to obtain this problem is the reverse one of the earlier problem. That means in the earlier problem we have given the circle which is in the form of sphere and plane, and we have asked to find the center and radius, but here the equation of sphere is given and center of the circle is given in the problem. We have to write the equation of the circle, means we are the circle sphere is given, we have to write the equation of plane only, and therefore what we can do is, see, you should solve this, the same figure will be there. This is the sphere, write its center, write its radius, and then the center of the circle is given. This is the center of the circle, and that coordinates are 2, 3, minus 4. These are the coordinates of center n are given. So we want to write the equation of this plane only, and then that equation can be written as, so we can get the coordinates of this C and n. From C and n we can get the DRS of the normal. So DRS of normal to the plane will be obtained by the difference of C and N from Cn. From C and N we can get DRS of the normal, and once the DRS of the normal are obtained, the equation of the plane will be x, that will be, we know DRS of the normal are, suppose ABC, then that is x a into x minus x1. See, the plane passes through this point, so that will be a into x minus 2 plus b into y minus 3 plus c into z minus of minus, that is plus 4, is equal to 0. So this is the equation of the plane, and this plane and this sphere together represents the circle. So that the answer is, the sphere equation is the same, and only we have to get this equation of plane, which is x plus 5y minus 7z minus 45 is equal to 0. So only this we have to obtain in the solution of the second problem. Figure will be the same. Find the equation of the plane. In earlier problem it was given, here it is asked. So if you get this equation together with this sphere represent the circle. So in this way try to solve this second problem yourself. Thank you for watching the lecture.